Well, hello, friends. Today we're going to look a little bit at some pipe issues because I was sitting on the train yesterday and just filing some bugs that I could think of. I filed this one about how we should send SIG-pipe when you try to write to a pipe that doesn't have anyone on the receiving end or the reading end, because we currently don't do that. And then I looked through the code because the thing is that if the signal is handled or ignored or blocked or whatever, then we're still supposed to e-pipe. And I searched for e-pipe in the code, and it seems like we're not very good about returning e-pipe. So I think we need to fix this up a little bit. And then I also noticed this thing that the tail program, it's currently missing some expected behavior. That the default thing that happens if you just run tail is that it should give you the last 10 lines of whatever the input is, even if it's standard input. At least that's how I think it works. Let's check here, tail. Well, yeah. Okay. So what happened, or the thing that interested me here was that I tried to do something like a tail n10 kernel map, and that doesn't work because we also need to do that. So tail needs some help with the argument comprehension, but I tried doing something like this and piping that to tail, and then notice the tail just prints usage and then hangs. And this isn't very right, but if we look at PS, then we can see that the tail process is dead, and the cat process, cat kernel.map, he is blocked in write. And I bet you that that's because the write call doesn't fail and return epipe, and nor does it sigpipe the process. So I think that's what we should be doing. So I thought I would just dig into this and try to implement that. So currently the way pipes are implemented is that they use this FIFO object, which is a first in first out implementation that inherits from file, and the file is the base class of anything that can be referenced by file descriptor is a file. So there are many types of file, and FIFO is one of them, but you can also have like a socket or an inode or character device or whatever. But yeah, so FIFO is one, and it's one that's used to implement pipes. And in the future, it should also be used to implement file system FIFOs or name pipes. Anyways, so currently, when you try to write to a file descriptor that's backed by a FIFO, you will end up here. And what this tells us is that if we have no readers, we just return 0. That's definitely not correct. So I think we should probably just fail with epipe there, and maybe that would fix our first problem of this thing hanging forever. What do I want to do? Tail. Nope, still hangs. Okay, well, I'm not gonna get that lucky. So cat still stuck in right. Okay. So let's see. So right will block. I'll show you how the blocking works actually. If you look in the sys right, on the right syscall, we go here and then, oh yeah, and then we call do write, because there are two ways of doing write, there's write and write v. But anyway, they both share this part. So the reason that we block is that we're here. It says, the descriptor tells us that he cannot write. And that usually just means that there's no space in the buffer currently, so you have to wait until the receiving end has removed stuff from the buffer, made some space for you. This thing is not perfect, but it works at the moment. Anyways, so what happens if you can't write? Then we block the current thread and we put it into this blocked write state. And then in the scheduler, when we look over all the threads and check if any of the blocked threads can be unblocked, we look for this condition here, thread. If the thread is in state block write, then we check if the blocked descriptor can write now. If so, then we unblock that thread. So that's how the block unblock thing works. And that happens on every scheduler iteration at the moment. So it's probably something that could be optimized further, but right now it happens on every scheduler iteration. So anyway, oh yeah, but you could see that actually, let me go back to the scheduler. You could see that the thing that makes it unblock is if can write will return true. And what that actually does is then checks, it just calls can write on the file. And since we have a FIFO, we should check what FIFO can write does. So currently FIFO can write only checks that there's space in the buffer. But we would like to also check if there are no readers anymore, because if there are no readers, then we should unblock and then allow the write to fail. So this is a little bit confusing sometimes, and I've heard other people say that it's confusing too. So maybe it's something that I think maybe there could be a better name for this that better describes what it does, because really what it's about is like deciding if the write system call would block or not whether you would like successfully write to the buffer and someone would read it. But anyway, I don't know the right name now, so I don't want to sit here and try to imagine the best name for it. But so the thing is, yeah, so if we don't have a reader, then we want it to come here so that we can fail. And I think that's the fix that we wanted here. So let's try that out. Yeah, there we go. So now we're failing here. Which seems reasonable. Although I would expect something to come out from the cat program because the cat program is supposed to print read error, but it doesn't. Because it's on standard out. So we need to actually redirect his errors to standard error. And we can actually just do, well, that one can look like that, but this one we can simplify. Say open failed, or no, that was a fine message. Okay, so we'll do that. So I think by doing that we should get that error message on standard error, so we should be able to see it. No? Why not? So let's see. Why does cat exit? Cat is 12. And I guess this is how we exit. Oh, wait, hold on. We were just checking read here. We're not actually checking what happens in the write. So let's do size t and written and live and read and written. if we have an error, then error write. Return some number that's not 0. Otherwise, we can also assert that n written in red, because if it's not, then we should handle that somehow, but we currently don't. Okay. Let's try this again. Here we go. Right. Broken pipe. Okay. That's more like it. So I like that. So let's do some commits here, because the changes to cat we can just kind of commit. It's just these things. So let's say git commit cat write error messages to standard. Also, fix some lack oversights in error handling. Error messages go to standard. Disappear in output. Also added check. Right. Okay. That's a nice little patch. And what else did we do? So yeah, so then in FIFO write, now we correctly epipe if there is no reader. So let's commit that as well. Or I'm just going to check that I'm not breaking some obvious thing here, but I don't think so. Just a cat kernel nap scrap bool. Finds a lot of bools and then returns. Okay. So let's say FIFO write fail with let write fail with epipe if there's no reader. Cool. Right then there was talk of this sig pipe thing. So I think, if I understand this right, then we should be sending sig pipe to the caller of write if he tries to write on a pipe and there's no reader. But where did I read that? I don't remember. Writing to pipe. Sent to a process when it attempts to write to a pipe whose read end has closed. But not vice versa. Right. So let's just assume that Brian by software engineer here, or Brian B, or however you pronounce that, let's just assume that he's the authoritative source on how Unix should work and go forward with that. So in FIFO write no readers. So I guess that would mean that we like current send. Oh god, I don't. Sending a signal to the current process. Haven't really been doing much of that. It's usually like sending it to someone else, or like doing a synchronous signal like a segfault or whatever. Actually, how does segfaulting work? I forget. Oh no, not here. Oh, we just set the termination signal. Right, so we're not actually sending the signal synchronously, we just crash on it. So DTY process send signal. Right, so we should send to the process, not to the thread. So current process send sig. Oh, shit, we need process as well. Send sig pipe. Wait, what was the sender? A process, right? So just a current. I'm sending it to myself. Okay, so how will that work? Well, let's just see what happens. So exited with status. So block shell use the signal, blah blah blah. Terminate due to signal. Cat. So signal 13. So here signal 13 kills cat. How do you do that again? Kill that shell. Signal 13, that's sig pipe. Okay, so the signal kills kills cat. That's correct. But we didn't print anything interesting about it, so I guess that would be in the shell. When we do wait pid. Oh yeah, but then we wait on all the children here. So maybe we should print out for each one what the exit status was, rather than just doing it for the last one. So we can do that, and then we can say like child is just the PID number. Okay, so I guess we can just do like this: PID D exited with status. So child, child. I think that's okay. Child D exited. Okay, and then we'll say child. Like that. And then child D exited abnormally. Oh, child. Because yeah, we shouldn't return. We have to keep iterating through all the children. So let's see. Exit status. Oh, I guess that should be like the very first child. So RC, what's that? Oh, it's here. Hold on. It's return value. Let's just say 0, and then we can do okay. And this allows us to do something like if I is 0, then Return value is the exit status. Okay. Back to tail. Child 12 exited due to signal. Child 13 exited with status 255. And wait pit fails. I guess it's okay if wait pit fails like that. Because that's Easter. Wait, no, this E child. So let's say, and no, it's not E child. We don't care about that. Like if we wait on something that's not there, it's fine. It doesn't matter. Because we're just concerned at the moment about cleaning up any child processes that we spawn from the shell. From the shell. Shell, not shell. Well, now we printed that twice. So that's a bit weird. Oh shit, right. So, because we're in this do loop here. Save, enter. Enter. Wait, what is it that I want to do? I wanted to not care about each child. Okay, so let's just not print it. Because, yeah, the loop is still controlled by enter. Because the thing is that enter is what you get from syscall if it's interrupted by a signal. It's unrelated to the pipe signal, but it's like if waitpid, if somebody signals the shell during waitpid, then waitpid will return enter. We have to handle that. But if waitpid simply fails because that child is no longer alive, that's okay. We should just not print. Kernel map tail. Yeah, okay, I think that's better. And then I guess tail failing is what exactly? It's tail CPP. Return tail from pause. Wait, no, hold on. It was exit -1. Oh yeah, so this is the one here. Right. So it's definitely a weird return value from a C++ program. So we're gonna return 1 for failure, not -1. And I should have noticed that when I was doing the review, but I did not. Because you don't always notice everything. Let's just make sure that we did that right. Sync. Just fixing everything here. Come on, tail. Okay, so now child 12 exits because of broken pipe, and then 13 exits with status 1. That's okay. And then if you're just doing things normally, then you don't get to see any of those. So it's pretty good. So what did we do? Let's commit those tail changes separately. Shell programs should return 1, not -1. Failing. To indicate failure. Let's just say it that way. Okay. And what did we do more today in the shell? Just fixing up so we loop over all the children. Okay, so let's commit that kernel change first of all. So that's in FIFO again. Where's that file system FIFO? Okay. FIFO. Race save pipe. Processes that try to write the right to yeah, and then in the shell go through all of the child processes. Check exit status. Let's just say check the exit status of all spawned child processes. Previously, we would only remember the exit status of, or no, well, whatever, that's okay. So is there something else that I would like to do? Yes, one thing is that the way that shell is currently saying like child and then the PID number, it's not the most user-friendly thing. It would be nice if it told me what the command was, so I can make sense of it. So let's see. Children. So the children are just the PIDs. But we could imagine making a little struct for this child process. It's called spawn the process. PID. Okay. And we can have something like that. And then it'll just be RHV0. Yeah, because RHV would build up here. And then we would just add that to the list. And then when we iterate over them, we'd say child.pig. And then when we print it out, we say child.name.characters instead of just child. Wait, why don't you like me? Oh, shit, yeah, because it's the %d. So we can say something like that. Child pig. Oops, just pig. Okay, let's try that. Oops, let's just run. I don't need to say child. But yeah, cat12 exited using the right. That's really cool. Okay. Let's commit that. Shell. Print the name of each process whose exit status we're reporting. Sure. Okay. So let's just see that one more time, I guess, because I think I'm gonna otherwise end it here, but I'm just gonna see that it looks just right. It's nice to test. Of course, tail doesn't work the way it's supposed to, but we're ignoring that now. We're just making this behavior right. Okay, so I think that's pretty good. So we fixed a bunch of pipe bugs, and although this and that made the shell a little bit better about telling you what happened with your command. So I think that's cool. And I will say that if you made it this far, then I thank you for watching and for coming back and for just being here and hanging out while I hack. It's really cool that so many of you are interested in this. So thank you. And I'll see you next time.